So after the completion of hydrostatics, we'll move on to hydrodynamics. What is hydrodynamics? When fluid is in motion. Initially, when fluid was at rest, we learned about various laws like Pascal's law and distribution of pressure across fluid. In hydrodynamics, there is a relative motion of fluid. Now, one very important aspect of hydrodynamics is called viscosity. And viscosity also in a way means fluid friction. Now, as the name suggests, you must have already gotten the idea what we are going to study about viscosity, that is fluid friction. See, viscosity, to understand the concept, before I'll explain you the definition of viscosity, to understand this concept, let's take an example. There is a beaker filled with water, okay? Now we are stirring it fastly with a spoon. It will achieve some velocity. The circular motion of all the fluid particles will achieve some velocity. Now, keep it at rest. Ultimately, the fluid is going to be at rest. Why? Because when there was this relative motion between fluid particles, because they were going in circles as we were stirring, right? When there was relative motion, the lowermost part of the beaker was in contact with the lowermost layer of the fluid, and there was an attractive force of bond formation between those two. That is, we are talking about adhesive or cohesive force. We are talking about cohesive force between the fluid and this beaker surface, right? So that is why this force of contact, like here, the force of attraction between lowermost layer and this surface which is already at rest, makes the lower surface or the lowermost layer of the fluid in rest. Now that layer will bring the next layer in rest, and this process will gradually follow till the top until the whole fluid is in rest, right? Now the important fact is that when I'm doing this, I'll achieve some velocity of the particles of this fluid, whatever it is. But if same fluid is now replaced with honey or another thick fluid, what will happen? I might not be able to achieve that velocity because this time it is very thicker. That means the internal resistive force which is inside the fluid is not making that motion possible. That is what viscosity means. Viscosity means, or it is an effect, it is a phenomena by which the fluid or an internal resistive force occurs between the layers of fluid because of relative motion between the layers of fluid. I would repeat that again. Viscosity is the phenomena due to which liquid layers opposes their relative motion when there is a relative motion between them, okay? So to understand the concept of viscosity, what we have done, we have taken two glass slabs, okay, and these are glass slabs, and between them pour some oil, okay. Now this glass slab is fixed, and the oil layer, consider this is an oil layer, okay. I've showed it like a rectangular segment, but let us say this is a large glass slab and this is oil layer. This glass slab is fixed, so I can apply a force on this glass slab, and it can actually reach some velocity. I can move it with some velocity, right, if the lower glass is fixed. But as I just said, if this thing or this fluid, oil, is replaced by honey, the relative motion between two glass slab won't be possible, or I won't be able to reach that velocity as I reached in the case of oil. So let us say this, due to this tangential force that is shearing force, there will be a shearing strain in the fluid, and it will reach like this. Let us say this relative motion made it to reach here, okay. So what is shearing strain? This one would be delta x and this one would be L, right? It is seen experimentally that the stress or shearing stress is directly proportional to rate of change of shearing strain or shearing rate. So rate of change of shearing strain means shearing strain over time, okay. Now if I just calculate this value, shearing strain upon time, that what would it be? This is delta x, shearing strain would be delta x upon L in whatever time it took to cover this small distance delta x, that is delta t. So this term here, which is delta x over delta t, is actually what? Velocity. So v upon L, this is what? rate of shearing strain or shearing rate, right? Now keep this term in mind. I am rubbing it out. So according to definition, viscosity, it is represented by this eta. Viscosity is the ratio of stress, that is tangential stress, to that of shearing rate. This is tangential stress over shearing rate, what we just described. So tangential stress would be this, because each stress has the same formula, force per unit area, and shearing rate would be V by L, right? So this gives me, this is equal to, viscosity is equal to FL upon A times V. This is one of the formula which you will be using in numericals. Now I can rewrite this formula as viscosity is equal to F over A V by L, right? What is V upon L? Velocity per unit length, that is velocity gradient. We have already discussed few terms with gradient, curl and divergence like stuff. When gradient means a physical quantity changing per unit length. So velocity upon length is velocity gradient. So it would be written by this. Instead of velocity gradient, it is dv upon dx. Rate of change of velocity with respect to length, dv over dx, right? This is another formula for viscosity which is very useful during numericals. Now, if I have to define viscosity, I can define it from this formula. Viscosity will be equal to F if area of cross section is how much? 1, and velocity gradient is 1. So how would I define viscosity from this formula? Viscosity of a fluid is defined as, viscosity of a fluid is equal to tangential force applied such that velocity gradient or rate of change of velocity with respect to length is 1, or in simpler words, let's rephrase it in simpler words, viscosity is equal to tangential force applied in a unit area of viscosity is defined as tangential force applied per unit area of a fluid so that the velocity gradient becomes unity, right? We have taken all the terms into consideration. This is how you define it. What would be the dimensional formula for viscosity? Okay, so dimensional formula is, either we can take this or this formula, take any one. Let's take the top one. Viscosity is, that we are talking about dimensional formula. So F is what? MLT minus 2, length L upon A, area is L square, velocity LT minus 1 meter per second, that is the SI unit. So this gives me L cube, we have an L square, so I am left with M, L minus 1 and T minus 2 plus 1, T minus 1. This would be the dimensional formula of viscosity. This is all we learn about viscosity.